Okay, it's time for us to do some algebra. Now we're going to be doing algebra all the way through this course. Now some of you might be struggling with algebra and kind of scared of it, but here's the good news. Eventually algebra will be the easiest part of physics. But we need to get to that point, so we need to practice this. So I want you guys, if you struggle with algebra, pay close attention and get lots of practice on this. There are really only two situations that we have to know how to do. The first one is what we call a one-term situation. One term on either side. Now I just want to make sure you guys understand what we mean by terms. If you have the expression 2x plus 3y, then what we have right here, notice that we have two different terms here that are separated by addition. So terms are separated by addition and subtraction. So I could add one more here, minus 5z, for example. Each of these are called terms, separated by addition and subtraction. Okay, so those are called terms, a little review of mathematics. And you'll notice when we're doing this one-term equation, take a look at we're going to do a little review of 2/3 x is equal to 12. You'll see that this one is one term, because there's no addition and subtraction, and there's one term on the other side. So we call these one-term equations. There's no addition and subtraction of terms. These are the simplest ones that we do. So let's talk about how to solve this one. Now can you see that in this question here, we are kind of dividing by 3. So we basically have this, 2x over 3 equal to 12. We are dividing by 3. Now usually what we want to do is we want to get rid of the fractions first. So whatever you're dividing by, we want to get rid of it. How do you get rid of dividing by 3? Well, what's the inverse, or if you wish, opposite of division? Answer, multiplication. So we are going to multiply this side by 3. Whatever you do to one side of the equation, don't forget to do to the other side of the equation to make sure they're equal. And much like when we're doing conversions, we have a 3 on the top, 3 on the bottom, so the 3's are going to cancel. So we end up with 2x equal to 36. See, we've got rid of the fractions. Now what we want to do is get the x by itself. We want to isolate the x. Well, can you see that we had 2x, that is 2 times x. To get rid of that, we have to do the opposite, if you wish, or inverse of multiplication. So what do? We divide by 2. That's the inverse of multiplication. And whatever you do to one side, do the same thing to the other side. And again, just to make sure this is clear, we have a 2 on the top, 2 on the bottom. The 2's will cancel. And now we're left with just x. So our answer will be x is equal to 18. Okay, so there's a review of math. Let's now talk about what we do in physics. In physics, we often deal with just letters. So imagine we have this equation. 3x is equal to y squared over z, and we're going to solve for y. We're going to get y by itself. So let me write this out. We have 3x equal to y squared over z. There's one term on either side. And again, if you want to try this yourself first, please do. Just pause and give it a try. First thing we typically do is get rid of the fractions to make our lives easier. So notice that we're dividing by z. Well, if you're dividing by z, we need to multiply by z. So always kind of multiply by whatever's on the denominator. Whatever you do to one side, do to the other side. And then this is where you can check you did it properly. Notice we have a z on the bottom and a z on the top. So those z's are going to cancel. One has to be on the top, one on the bottom. And this leaves us with 3xz equal to y squared. Good. One more thing we have to do. To get the y by itself, we need to get rid of the square. What do we do to both sides to eliminate the square? Well, we do the inverse of squaring, which is square rooting. So we take the square root of one side. Whatever you do to one side, do to the other. Good? Now, if you're an expert in math, you'll realize that there was something missing here. If you actually do x squared is equal to 25, for example, and you take the square root of both sides, and you get the answer of x is equal to 5, you realize there's actually more than one answer here. 5 is not the only answer. It could also be -5, because -5 squared is equal to 25. So we typically put a plus or minus in front to acknowledge there's two possible answers. So technically, we should be putting a plus or minus in front of that square root. In physics, though, we don't get too worried about that in most of our questions. It doesn't show up too often. Anyways, the square and the square root are kind of cancel each other out, if you want to think of it that way. And we end up having y is equal to plus or minus the square root of 3xz. But if you guys put the square root of 3xz, we'd still give you full marks. Good? That's one term. Let's try two terms, or multiple terms. Okay, so if you take a look at our equation down here, 4x minus 7 is equal to 13, you'll see that now we have addition and subtraction. So I'm going to write it out nice and big here. So 4x minus 7 equal to 13. And I'm just going to make sure you guys are clear. Here's a term, here's a term, and here's a term. So notice that there are two terms on that left-hand side. We don't care so much that 13 is a term. What really matters is you have two terms on the left-hand side, and we're trying to solve for x. So essentially our variable is right here. Now what you're supposed to do in math is that if you're going to solve for x, you need to get the other term out of there first. Get that term by itself first. So for some people, when you do this, -7 becomes +7. If you want to show it another way, you can do again the inverse. You're doing subtraction, -7, so you're going to add 7 to both sides. You can do that as well. Whatever kind of work you guys need to show. Good? So regardless, you will eventually end up with 4x plus 0 equal to 20. Good? So whatever kind of work you need to show to get to that point. Now when I teach this course, we'll just talk about moving it to the other side. It's -7, it becomes +7. So 13 plus 7. Finally, we want to get x by itself. Now we've already talked about that. We're multiplying by 4. So you do the inverse or opposite. So now we divide by 4 to both sides. And the 4's cancel. Oops. And we have x is equal to 5. Good? A little walk down memory lane. So, key thing is, this is the most important thing, is that you're going to get the term by itself first. And typically, it's by addition and subtraction. And that's why we got the -7 out of there. So, here comes a physics kind of question. I'm just going to rewrite this a little bit before you guys try it. Here we have d is equal to vt minus 1/2. I really recommend you change 1/2 to 0.5 at squared. If you guys want to give this a try to get v by itself, please do. Pause, give it a try. Okay, so I'm just going to, again, highlight the terms. Vt is one term, and the 1/2 at squared is the other term. There are two terms on this side. And notice that v is what we're looking for. That's the term we care about. So what we need to do is to move the second term to the other side. Notice it's minus 1/2 at squared, so it becomes positive 1/2 at squared. Or, again, if you feel comfortable doing this, you add 1/2 at squared to this side, and you do the exact same thing to the other side. Okay, however much work you guys need to show. We end up getting d plus 0.5 at squared is equal to vt. Good. That's usually the most important step, to get the term by itself first, because from here we now only have one term, vt, and we do what we typically do. So you'll notice that v is being multiplied by t, so how do you get rid of the t? We divide by t, and you do the exact same thing to the entire other side, divide by t. And if you want to show this, t's will cancel, and then there's our answer, actually. So v becomes equal to d plus 1/2 at squared over t. Done. So this is considered excellence level. This is a little bit of a harder question, but this is what you guys need to rise up to. So really, if you struggle with algebra, practice, practice, practice. Get used to using letters like this. I'll see you in the next part of the lesson.